This is question number 2 of the damping and resonance homework, and here we have a student studying the motion of a pendulum, which is given by the equation there. We've got lots of different time periods, time periods for different lengths, and plotted a graph of t against delta root L in order to choose a value for g. A really common experiment here, the free fall acceleration. Explain why these are poorly chosen. There's lots of different reasons for these. One is we've not chosen a suitable number of different values. We've only effectively chosen 4. 1, 2, 3, 4. The other reason I think is that 0.1 is a little bit too short. If we think about what the time period for that is going to be, it's going to be L divided by G, which that's going to be 0.01 square rooted back to 0.1 multiplied by 2 pi. So I think the time period for that one is going to be about 0.6 seconds. So that's going to be really, really quite quick. I think another answer would be that they've not taken a suitable range, that actually that's too small and this is not big enough. It's perfectly feasible in a laboratory to take a pendulum with a length of 2.5 metres, something like that. Why they're poorly chosen there, I think that kind of sums up everything there. So you need to plot and plotted a graph. So moving on to the next, how would you obtain a value for g from these graphs? Rearranging the equation to y equals mx plus c is really, really common. T equals 2 pi root L over g. So they were plotting, let me just go back to what they were plotting, a graph of t against root L. So t is on our y-axis. So we want this in the form of y equals mx plus c is what we're looking for here. And you can see that they've separated out the L. So what you want to do is get what is plotted on the x-axis on its own. So I'm going to write this in a slightly peculiar way, to root pi g over L. So what you can see here, t on the y-axis, root L on the x-axis, which means that our gradient is 2 pi root g. Now, AQA are a bit funny with this. We'll come to this later on, but you do need to be explicit. So, in your answer, so the gradient, capital G is what they normally refer to it in the exam, or a little m you can use, 2 pi root g, and therefore root g equals 2 pi over g. And then we've got g equals 4 pi squared over capital G, or your gradient. So doing your answer, do the rearrangement. It's no good just saying the gradient is 2 pi root over root g. That doesn't tell you how you calculate g from your gradient. You need to do this rearrangement there. The graph below shows 3 oscillations for an undamped pendulum of 1 metre. Add magnitudes to the time axis. So we need to work out what the time period for this pendulum is. So we're going to use this equation here. We're going to go t equals 2 pi root L over g. 2 pi root L1 over 9.81. So I think it should be about 2.00 seconds. Yep, and then one complete oscillation starts at the origin there, so that's going to be 2, that's going to be, not 2, 4, and that's going to be 6. When it's lightly damped in air, so what we want is we want it to complete many oscillations, so but it's going to be slightly less after each one. So as long as your amplitude after each oscillation is reduced, so it should be under this black line printed already, and it should be successively decreasing, and it should have an equal time period there as it's lightly damped.